and welcome to the third video in this Learn C# series. Today we're going to be covering data type basics and jump into custom types too. If you're new here, I have an upcoming internship that requires I know C# and I don't really know any of it, but I find the best way of learning is actually by teaching, so I've created this series. It's not necessary that you know any prior programming knowledge, but it will help you follow along. In this series, we'll be following C# 12 in the nutshell. Let's go ahead and get right into it. In the last video, we covered our first program that printed hello world. Then we also discussed the using system statement, which is just importing all of the classes or types that are within system. And then we talked a little bit about variables and methods. And here we are going into a deeper dive into predefined types and some of our own custom types. Let's evaluate lines 3 and 6 here. On line 3, we have int sum equals 1 plus 2. Let's start with int. Int is saying that this is going to be an integer, and this is defining a template, if you want to say, of how large this data it can be. So int says that there are going to be 4 bytes in memory or 32 bits, and the first bit is going to be the sign bit, saying whether or not the number is positive or negative. The remaining 31 bits determine the precision of the variable or its range. Variables can change. So although we have sum is equal to 1 plus 2, which would be 3, we can then go on and say sum is actually equal to 0. Variables can change, but on line 7, we have a const double pi equals 3.14. Const is saying that this value is never going to change. It's constant. And here is a new data type that we're looking at, which is double. Doubles are similar to ints, but except we can hold decimal places afterward. So here we have 3.14. The 0.14 can be there due to IEEE floating point numbers, and that's a whole nother rabbit hole to go down with when you want to start talking about the mantissa and other things. But just know doubles hold decimal places. If we try to go ahead and change this value, so I can say pi is equal to 0 here, we get a compile error. It doesn't work because this is a constant. All variables are constants are instances of their data type. So here sum is an instance of an integer. Pi over here is an instance of double. Again, data types are just a predefined template of the range of values that a certain instance of that data type can have. Here in this table from Microsoft C# documentation, you can see all the ranges of values for all the different types of whole number values that they have. C# gives us a bunch of predefined types to work with. You've already seen integer and you've already seen double, but we also have things like strings. Strings are just a sequence of characters that represent basically text. So I can have a string down here called name, and we can set that equal to Colton. Strings must be encapsulated inside of two double quotes, basically saying between these two quotes is the string that I want to have. The quotes inside are not, or on the outside are not included. If we wanted to have a character, a single character, we could also do char and C, and then we could set that equal to, let's just go with the letter C here. Since this is not a string and just a character, we encapsulate it with single quotes. Outside of the number types and the kind of string or character types, we also have another one, which is Boolean. Boolean values can take on either true or false, and these are typically used within if conditions to evaluate if some sort of expression is true or not, and if it is true, then we can go ahead and execute the following statements in the if. So over here I have a boolean called b, and that's equal to true. That's all we need to have. So if I have a statement down here that says if b, or we can say if b is equal to true, then we can go ahead and say console dot right line it was true, and then we can close that off and we can run the program. Here we get it was true. What if we go ahead and negate this? So if b is false, which given what we already have, this is going to, since b is true, b is not false here, so this will not run. Let's go ahead and run the program, and there we go, we get no output. Booleans are just a single bit in memory, either a 0 or a 1, true or false, and we can also have expressions assigned to the value. So instead of having the literal true right here, we can say if 5 is greater than 10. Since 5 is not greater than 10, b is actually going to be false right here, which will make this statement true. So we will say it is, or it was true. Let's go back to the string data type that we have. There are a plethora of methods to manipulate the strings, concatenate them, and all sorts of stuff that you might want to do with a string. So for instance, we have the toUpper method. So if we say name.toUpper, this will actually not do anything because strings are immutable. So let's go ahead and write a console.writeLine and then just print the name here. We will only get Colton as it is right here because this does not modify what is going on in the string actually. This just returns another reference to a new string. But let's go ahead and make sure that this is correct. So we run it and we get just normal Colton. But if we were to assign name to this new name that toUpper is returning to us, we're going to get Colton in all caps. What if we're doing some sort of input and we want to get rid of white space on both the left and right sides of a string? Let's go ahead and do a bunch of white space right here and then maybe on the other side, and let's go ahead and trim this. So there's a trim method that we can call, and you just say trim with both the parentheses, and let's run it and make sure, and there we get Colton. We can also chain a bunch of methods together. So we can say trim and then do a toUpper, and let's make sure that this is going to print just Colton in all caps with no white space on either side, and there we go, that works too. There are several other methods that you can go look at over on Microsoft C# documentation. That could take you a good long time to sit down and read. Now the question is, how do we define our own types? Sure, if we wanted to take an abstraction of a cat and say every cat is going to be represented in our program by having a name, fur color, age, and so on and so forth, that's valid. We could have, say, let's say 3 variables. So we could go with a string cat name is equal to Mochi, let's say, like my cat, and then have an int age, or we'll call it cat age, is equal to he's like 3. But what if we wanted to have like multiple cats? Suddenly scaling this becomes much more difficult. We need to have multiple variables holding all these types of stuff, and it just becomes a quick mess. But what if we just defined our own type called cat? So instead, what we can do is just create a public class called cat and then put all of the data that we want a cat to have inside of here. So here we can just say every cat is going to have a name that's of type string, and also every cat is going to have some sort of age and then maybe a fur color. These are attributes of the class, or sometimes you might hear them called fields. These belong to every instance of a cat. So in order to create our own cat, we must have what is called a constructor. A constructor is very similar to a method, except it's a one-use method. If we wanted to create a cat in other classes or other files, we need to say public cat and then pass in what it takes to make a cat. It is valid if we just want to do string name and end it there, but we also have 2 other attributes that we might be interested in instantiating. So here we can go ahead and say it's going to take an int age and then another string called fur color. So every time I go to create a new cat, I need to pass in the name, age, and a fur color. Now, a question that you might have is, how do we assign these to maybe a new instance of a cat, especially when the parameter names appear the same exact the attribute names that we have here? Well, we can stop this shadowing by directly referencing the instance that we would be working on. So we could say this .name, referring to the object that we are currently allocating right now, is equal to the name that I was passed in up in the parameters of the arguments. And then we just repeat this. So we can say this .age is equal to age, and this .fur color is equal to fur color. There we go, that's our constructor. But just keep in mind, our constructors don't always have to have every single attribute that is contained up here. It can just have the name, and then we could instantiate age to just 0 and fur color to white or some other kind of color. Now let's actually create an instance of this cat. So here we give the data type that we want it to be, the variable name that it's going to have, and then set it equal to a new cat, and then we just pass in all the information that we want to have. So the cat's name is Mochi, his age is 3, and he is a black cat. And so we just end it right here, and there we go. This is a valid initialization of a cat. But how can we prove that this data is actually going to the cat variable? Let's go ahead and do a console.writeLine. In here, we can just access the cat name of this instance and just say cat.name. but we're gonna get an error. In order for us to access the name attribute of this cat variable, down here in the cat class, we need to say that name is publicly accessible. All we need to do is put public before the string part. So we just write public, and then there we go. We can go ahead and print out the name. Let's run it, and we see Mochi right down here. Similar goes for the other two fields or members of this class, age and fur color. We cannot access them until we put public before it. But another question arises of what if we have some sort of class and we have a member that's not specific to one instance of the class, but maybe the class as a whole. Let's say that we wanted to keep track of how many cats we've made so far in the program. Well, we don't want every single cat to hold how many cats its parent template is holding. Instead, we can just make a static member of the class. So down here, let's do a public static int num cats is equal to 0. So once this class is compiled, we're going to see that num cats is equal to 0. But once we make our first cat, we should try to increment this. So down here in the constructor, let's just say this dot num cats is equal to num cats plus 1. Oh, I'm sorry, cats dot num cats, because again, static members are not a part of a specific instance. So cat dot num cats equals num cats plus 1. So let's go up here and see what would be printed to the console. Console dot write line. We could say cat dot population, or sorry, we're not even using population, we're using num cats. So num cats, and then let's go ahead and print this again after we make a cat. And so it should be 0 and then 1. And as we can see, 0 and 1 was printed. And that's basically how static members work. It's kind of to keep track of things that belong to the class rather than a specific instance of the class. Next, this class needs some kind of functionality or behavior to do anything. It's great that we can store information about every instance of a cat, but if we can just store information about it and they can't really do anything, then what's the point? So every cat should be able to meow. So let's go ahead and create a new method, public void. So this is going to be a publicly accessible method to every cat, and it's not going to return anything. And the method name is going to be meow. It's going to take in no arguments. Right here, it'll just be a console.write line, and it will say meow. So if we go ahead and remove our numcats lines and we just say cat.meow here, then we should see meow printed to the screen. And there we go. What we have right now is a very small program that's just creating a new cat and having it meow. But when we go on to work on larger applications, we're going to need more and more classes, maybe like a person, maybe something to represent a building, other things like that. And naturally, some of these classes that we're going to be making will have very similar qualities. So for instance, we can have a cat and we could also have a dog. These are both pets or animals, so therefore they should be grouped into a namespace. Now this is something that you should already be familiar with. We're using the system namespace up here to interact with some of the lower components in our system, such as like input and output for the console.writeLine. So let's go ahead and copy this and then create a namespace. So we can just say namespace and then encapsulate it right inside of here. But we're going to get a little bit of an issue. No longer can we just say cat anymore. We have to say, oh, well, we also must name this namespace. So we can go ahead and say pets. In our pets namespace, we can hold pets. And the tabs are a little bit off here, but you get the point. But we can no longer just say cat equals new cat, because now cat is organized into a namespace. So instead, we must say pets.cat equals a new pets.cat. And there we go. It works just fine. We still get the meow. But again, just like what we learned in the last video of that we don't want to write system.console.writeLine every time, we can do the same thing. We can just say using pets up above, and therefore we can go ahead and get rid of the pets prefix and everything works as is. There's one more thing that I'd like to cover before we leave. In all of the previous videos and the little mini programs that we've made so far, we've been using what are called top level statements. Top level statements are just statements that are ran when we don't have a main method to run. A main method is usually the main method that is going to be executed in a program, or it's the entry point of any program. In absence of a main method, we can just use top level statements, and you can also relate this over to like Python, but it's not necessarily good practice to just just be using top level statements. These kind of statements should only be used when you're doing quick tests and other things alike. Instead, we can organize this into a class. So we can go into public class cat, and then above maybe our constructor, we can have a static void main method here that organizes what we previously had at the top down into the main method. So then once we run this, we will go ahead and get the meow printed out still. So if I go up to my language up here at the top and change it to C# program rather than the statements that we were just running, hit the run button, we get meow, because now the compiler is looking for where the main method is located and executing the statements within. We cannot have multiple main methods in our program because then that would cause ambiguity, saying, well, which main method should I really choose to run? All right, that's gonna do it for today. Today we covered predefined types like int, string, double, and a boolean. And then we went into our own custom types where we wanted to create a cat, or you can do the same thing, create maybe what represents like a business or a school, where every class has some sort of data associated with it that's only accessible to other classes if we use public beforehand. Then we went into the static members of a class. So these are things that don't belong to a specific instance of a class, like down here in the cat. We actually have to call the cat class instead to access numCats. Then we went into constructors and how to create new instances of a class, and then also talked about methods that belong to an instance of the class. Very similar, if we made this static, then we could just call the cat class static methods. So if you want to relate this over to the console.writeLine, writeLine is a static method that is accessible without creating a console instance. Lastly, we touched on the main method and how main methods are the main entry point into a program. If you learned something today, consider hitting the like button and subscribing, and I'll see you in the next one.